You want to learn a little more about quadratics and their graphs? I will show you. A quadratic equation is just an equation with an x squared and a u-shaped graph. The graph is called a parabola. That's just the shape. And a quadratic equation always comes in the form y equals a times x minus h squared plus k. And a, h, and k are just constants. That's just any number. The parent function of a quadratic is the basic equation, and that is y equals x squared. That's where all the constants are 1, 0, and 0. This graph is easy to remember because it just looks like a giant U, and it's centered at 0, the origin. But we can change around quadratic equations if we change up the constants and make them different numbers. We can change a, h, and k to make the graph wider or narrower, face up or down, but it'll always be that same basic curve shape. The origins can also be in different spots. Let's first start with a constant a. If a is positive, the graph is going to face up, but if a is negative, the graph is going to face down. If we have y equals negative x squared, the graph is like a giant arch. It faces down. Also, if a is less than 1 but greater than 0, we could also call that a fraction, the graph is going to be wider than the parent function. We can see as the fractions get smaller, the graph gets wider and wider. Let's look at the comparison between the parent function, y equals x squared, and y equals a half x squared, y equals a fourth x squared, and y equals an eighth x squared. Those are all between 0 and 1, and the graph gets gradually wider and wider. You can see the progression. But if a is bigger than 1, the graph is going to be narrow. The bigger the a above 1, the more narrow the graph. So a graph of y equals 8x squared would be much narrower than y equals 2x squared, say. The next constant is h. H is just a horizontal shift, so that's a shift along the x-axis. If h is positive or greater than 0, the graph is going to shift to the right. But if h is negative, the graph is going to shift to the left. This makes sense because we know that the negative x's are on the left side and the positive x's are on the right, like a number line. We have to know how to calculate h, though, because it's not as simple as just taking the number out of the equation. Since a basic quadratic equation is a times x minus h squared plus k, that's an extra negative sign that we need to take into account. So if we have y equals x plus h squared, we actually solve for h by writing y equals x minus a negative 6, because two negatives make a positive. That means that h is negative 6 here. And since we know that a negative h shifts to the left, this graph is going to shift 6 units to the left, as you can see from the original function. If we remember how to solve for h, we can remember the direction of the shift. If we look at a few examples, y equals x minus 3 squared, h is a positive 3, so the graph shifts right. If y is x plus 2 squared, h is a negative 2, and the graph shifts left. And one more, if y equals x minus 1 squared, h is 1, and the graph shifts right. Another way to look at this is if the sign between the x and the h is positive, the graph is going to shift left. But if the sign is negative, the graph is going to shift right. So you just remember that the sign of the h is opposite of the sign in between x and h. So now you have two ways to remember. The last constant is k. That represents a vertical shift in the graph. So we can go up along the y-axis or down. If we have, let's say, y equals x squared plus 7, that's going to be 7 units up that we shift the graph. And if we had a negative 7, it would be 7 down on the graph from the origin.